Unit 2B, Lesson 3, Key Features of Graphs. So in this lesson, we're going to talk about a lot of vocabulary and notation, how to write and identify some of these features when looking at the graphs of various functions. In this lesson, we're going to be talking a lot about quadratic functions. Next, we're going to look at the graphs of quadratic functions, talk about some of the main ideas. So first of all, the name given for the graph of a quadratic function is called a parabola. It's going to be a U-shaped, and you'll see that once we start graphing some of these examples. The standard form for a quadratic function is y equals a times x squared plus b times x plus c. The vertex refers to the minimum or maximum value of a quadratic. The expression we use to find the x-coordinate of the vertex when it's in standard form is x equals the opposite of b divided by 2 times a. We get these b and a values from the standard form of the quadratic function. And then we also have a vertex form. So we have a standard form and we have a vertex form. The vertex form is y equals a times the quantity of x minus h squared plus k. When it's in vertex form, it's easy to identify what the vertex is going to be. It's the ordered pair hk. So h is the x-coordinate of the vertex, k is the y-coordinate of the vertex. So two different ways we can write quadratic equations, standard form and vertex form. The vertex is the minimum or maximum of the quadratic. The parabola, that's the name given for the graph of the quadratic. Some of the key features we're going to look at with parabolas are the vertex, the axis of symmetry, the intercepts, intervals of increasing, decreasing, intervals where the graph is positive and negative, and whether the graph opens up or down. Okay, so these are all the different features we're going to analyze with the parabola. Now to the first example, we want to use a table of values to graph the quadratic function. Our equation is y equals x squared minus 2x minus 3. So this is given to us in standard form. We're going to use a table of values, 5 points. We'll plot those points, draw the graph for this quadratic function. The first thing we should do is find the x-coordinate of the vertex of the graph. So we have to use the expression x equals negative b over 2 times a. So we're looking for the opposite of the b value in standard form. The b value is the value multiplied in front of x. So the opposite of negative 2 is a positive 2. So we have 2 divided by 2 times the a value. The a value is the value multiplied in front of x squared, which in this case is going to be 1. So 2 divided by 2 times 1 is just going to be 1. That represents the x-coordinate of the vertex for this graph, this quadratic. We want to put that value in the middle of our table of values for inputs. And then we're going to pick some values less than. We can just go 0, negative 1, and then we can go values greater than 2 and 3. We always want to find the x-coordinate of our vertex and make that the middle value because the graph is going to be symmetric with this parabola. Now we just have to plug all of these x values into the equation to find the corresponding y values. So for instance, if we plugged in negative 1 squared would be 1. Negative 2 times negative 1 is going to be a positive 2. So we'd have 1 plus 2, which is 3. 3 minus 3, that's going to give us a value of 0. If we plug 0 in for x, these first two terms become 0. So we'd have negative 3. If we plug 1 in, 1 squared is 1, minus 2 is negative 1, negative 1 minus 3, negative 4. If we plug 2 in for x, 2 squared is 4, minus 2 times 2 is 4, so 4 minus 4 is 0, 0 minus 3, we get negative 3. Now if we plug 3 in for x, 3 squared is 9, negative 2 times 3 is negative 6, so 9 minus 6 is 3, 3 minus 3 gives us a value of 0. So now we want to plot all these points on the coordinate plane. and then we're going to construct a smooth curve through them. So once we plot all those ordered pairs, we construct a smooth curve through the graph. This isn't a point, it's not a V, it's more of a U-shaped. That's what the parabola is. And you can notice some things about the graph. Our vertex, which was 1, -4, that is going to be the minimum value for this particular graph. And you can see if we drew a vertical line through the vertex, our graph is going to be symmetric. It has that mirrored image created on both sides of that. This is called the line of symmetry. It goes through the vertex. It has a mirrored image on both sides. It's symmetric. Okay. So first thing, when you're graphing using a table of values, make sure to find the x-coordinate of the vertex. Use that as our center, because then we can get a better approximation for the graph because it's symmetric on both sides of the vertex. The next example, we want to use the same idea, use a table of values to graph the quadratic function. Now this one is written in vertex form. So the first thing we should be able to do when creating a table of values is find the vertex. When it's in vertex form, it's a lot easier to identify that rather than use that expression. So the general or the main form for vertex form is a times x minus h. H represents the first or the x-coordinate of the vertex. So this is x minus 2. Thus, the x-coordinate of our vertex is 2. At the end, plus k, we can see we have plus 3. So the y-coordinate of the vertex is going to be 3. Now we want to pick values that are less than 1 and 0. We can use 3 and 4. Just like last time, now go through, plug all these x values in to find the corresponding y values. So now you have all those ordered pairs, you plot the points, construct a smooth curve through all those points. This time you can see the graph's a little bit different because it opens down, and that's going to be because of this negative value out in front of the quadratic. That negative means it's going to open upside down, it's going to be a frown face. Again, if we looked at our x value of 2 for the vertex, if we drew a vertical line going through that, that would be our axis of symmetry, creates that mirrored image symmetry on both sides of that axis. In this next example, we're going to look at the graph of a function and identify key features based on the graph. So we're going to identify the vertex, axis of symmetry, x-intercepts, intervals of increasing, decreasing, intervals where it's positive and negative, and then whether the graph opens up or down. So first we're going to look at the vertex of the graph, which is going to be the maximum or the minimum value of the graph. In this case, it's going to be the minimum value. So we look at this ordered pair that occurs at -2, -3. So that is the vertex of our graph, -2, -3. Next, we want to identify the axis of symmetry, and that's going to be a vertical line that goes through our function that's going to create a mirrored image on both sides of that line. So if we have a vertical line, we know it's going to be x equals some value, and that value is going to be the x-coordinate of the vertex. So our axis of symmetry is going to be x equals -2. Make sure you write x equals -2. This represents a line. You can't just put down -2. Now we're going to identify the x-intercepts of the graph. In this case, there's going to be 2 x-intercepts. There's 2 points where the function, the graph, crosses the x-axis. First one occurs at an x value of 1. The other one occurs at an x value of -5. So how we can write these is as ordered pairs. 1, 0, and -5, 0. We know if we have an x-intercept, by definition, the y value is going to be 0. Now we need to identify intervals of increasing, decreasing, and our intervals are going to show the x values for where our function values are either increasing, going up, or decreasing, going down. So first we'll start with where our function is increasing, okay, the intervals where it's increasing. So if we're going from left to right with our x values, we're looking for what x values give us function values, y values, that are going up. So if I look at the value of x equals -2, when I start at -2 and I start going to the right with my x values, I could see the function values start going up. Before that, if I'm going from left to right, my function values are going down, they're decreasing. So where they first start to increase is at an x value of -2, and then as they go to the right, and this is going to continue to the right, we could see this arrow at the end of our graph means this function is going to continue this pattern, this behavior. So from -2, that x value, to an x value of infinity, because that behavior is not going to end, it's going to continue, our function is going to be increasing. Now if we're looking at where our function is decreasing, this behavior is going to continue as we go to the left. So if we're starting from the left, we can see our function values as we go to the right. Starting from the left and going to the right, our function values are going down, they're decreasing until we get to that x value of -2. So from -infinity, as we come from the left until we get to an x value of -2, that function is going to be decreasing. And we're going to use parentheses on these endpoints. You always use parentheses on infinity and -infinity. We're going to use parentheses on -2 as well, because at -2, the function is neither increasing or decreasing. It's kind of stalemate. That's a turning point. So we're going to use parentheses on those endpoints. Now we're going to go through intervals where the function is positive and where it's negative. First, we're going to go for the intervals where it's positive. So we're looking for the x values where the function values or the y values are going to be positive, where those values are above the x-axis. So we have two different portions where our function, the y values, are positive. From -infinity until we get to this x value of -5. So from -infinity to that x value of -5, again, we're going to use a parenthesis because at -5, it's neither positive or negative, it's 0, it's that neutral value. It's also going to be positive from that x value of 1 until infinity. So we use this symbol that looks like a U, that's called the union. It means this interval or this interval, that's where the function is going to be positive. So from 1 to infinity. So from -infinity to -5, our function is positive, or from 1 to infinity, those values as well. Now we're going to look at the intervals where our function is negative, where it's below the x-axis. Well, that occurs from -5 until we get to that value of 1. So from -5 to 1, parentheses on both of those as well. The last thing we need to look at is whether the graph opens up or down. We can see in this case it looks like a smiley face. Our graph opens up. Brown face, our graph would open down. So far in this lesson, we've talked about quadratic functions. To end the lesson, we're just briefly going to talk about absolute value functions. The standard form for an absolute value function is y equals a, and then times the quantity, the absolute value of x minus h plus k. The vertex, just like the quadratic equation, is going to be the ordered pair, hk. And then to determine whether it's going to open up or down, again, that's looking at the value of a out in front. If a is positive, the graph opens up. If a is negative, then the graph is going to open down. So the last example, we want to graph the absolute value function. We have the equation y equals 2 times the absolute value of x minus 1 minus 3. First thing we should do is find the vertex, which is going to be the ordered pair hk. Our h value is 1. Our k value is -3. So now we got to pick some other x coordinates, 0, -1. Then we can use 2 and 3. Just like before, now we just have to plug these x values in, find the corresponding y values, plot these points, draw our graph through there. So we get our y values, we plot those ordered pairs, and now the difference between this graph and the quadratic that we just talked about is that an absolute value is going to have a v. Where this vertex occurs, there's going to be a corner. So it forms a V. A parabola is a U-shaped, an absolute value is a V-shaped. Okay. If we had had a negative value out in front, then just like the quadratic functions, then our graph would open down. In this lesson, we talked about a lot of vocabulary and new ideas, concepts. Make sure you have a basic understanding of all of these topics, the different forms, how to identify the vertex. One thing we will spend a lot of time on in class is how to write the intervals of increasing, decreasing, and where the intervals where the function is positive, negative, because normally that's going to be a difficult thing to understand when trying to use that notation.